2018 AB number 2. We have a position velocity acceleration question here, which is everybody's favorite. I have to tell you guys, I am at the point where anytime I get a crazy mother function on number 1 or number 2 on the calculator active section, I'm just automatically putting them in my Y editor, meaning I'm putting them in to be graphed. Even if I never actually look at the graph, I'm going to use that fact that it's in the Y editor to take derivatives, to take antiderivatives, all that good stuff. So I put V of t into my calculator under Y1 right away. And for part A, when it asks to find the acceleration, you guys see how it doesn't ask you to show your work. It doesn't ask you to justify your answer. It doesn't ask for anything. It just asks for the acceleration of the particle. So what you need to tell them is that you know that acceleration of the particle, at time t equals 3 is equal to the derivative of the velocity function at t equals 3. And then you're using your calculator to take that derivative, and you end up with negative 2.118. Sorry, my decimal places don't want to go on here. All right, and that's all you need for part A. For part B, it's asking you for a position of the particle. Well, it gave you a position of the particle. It gave you the rate of change of the position of the particle. And it's asking you for a new position of the particle. So guess what you do? You do new equals old plus net change. The new value here is going to be my position at time 3, and that's going to equal the old value, my position at time 0, plus the integral from 0 to 3, from old to new, of my velocity function. Now, I'm going to put V of t in here very specifically because if I enter it wrong on the calculator, I might lose a point for the answer, but if I accidentally write it wrong inside this integral, I'm not going to lose the point for the integral, and I don't want to do that. So I'm going to call it V of t. X of 0, they tell me, is negative 5, so I'm going to put negative 5 plus this integral into my calculator, all in one line, and I'm going to come up with the answer of negative 1.760. Okay, and that's the answer, either truncated, meaning you chopped it off after 3 decimal places, or rounded. You need an answer correct to 3 decimal places. Please give it 3 decimal places. Okay, next in part C, and here's, I'm loving the fact that I put this in Y editor because I took my derivative for part A in Y editor. I took my integral from part B, not in Y editor, but using the fact that it was in Y1 and I recalled it as Y1 instead of having to retype it. I used it for part B. I'm going to use it for part C now. So I'm going to just literally on the calculator integrate the integral from 0 to 3.5 of V of t dt. Okay, and that gives me 2.843 or 2.844. Either answer is acceptable. There is no other acceptable answer. And then I'm also going to integrate from 0 to 3.5 the absolute value of velocity, and this should give me a bigger number, and I get 0.737, which is the only acceptable answer, whether or not you cut it off or round it. Okay, now it asks to interpret the meaning of each integral in the context of the problem. Now, usually it would say give it with correct units, but there is no unit indication anywhere here. Okay, so what I need you guys to recognize is that your integral without absolute value bars is the net change in position. You might want to throw around the fancy word of displacement, but it's the net change in position of the particle. Just looking to see if they call it an object or a particle. Between t equals 0 and t equals 3.5. Okay, you might want to more specifically say that this tells us we ended up 2.843 units to the right of my initial position at t equals 3.5. Okay, but just saying it's the net change in position or the displacement of the particle between t equals 0 and t equals 3.5. And when I throw absolute value bars on there, this is the total distance traveled. The integral of speed, which is the absolute value of velocity, gives you total distance traveled by the particle between t equals 0 and t equals 3.5. Very, very, very important that you know the difference between a net change in position and total distance traveled. The integral of the absolute value of velocity is total distance traveled. You will be tested on this at least once on your AP exam, and most likely on the free response portion. Okay, so it's in addition to the multiple choice. You need to know the difference between distance and displacement, or total distance and net change in position. Luckily, part D is an easy end to a problem who I gotta say, it's really not that bad. So we have a second particle moving along the x-axis now. Our position function is given. So our first particle, we got a velocity function. Our second particle, we're given a position function. And I want the velocities to be the same. So I literally want to have x prime, which would be 2t minus 1, to equal v of t, that whole nastiness up top. And I'm going to solve this on my calculator. Okay, so only looking on this window from 0 to 3.5, and I'm looking for points of intersection, and I'm using my calculator to do it. Once again, makes me really happy that I graphed that velocity function the second, or I put it in the y-editor the second I started this problem. And now I just have to enter one more function and look for a point of intersection. After the two functions, I see there's exactly one point of intersection. It happens sometime between t equals 1 and t equals 2. And if I use the calculator to solve it, I get t equals 1.570 or 1.571. Either answer is acceptable. There are no other acceptable answers. And that's it. Not bad for a motion question. I kind of like this one.